Hey, guys and girls. So, want to get you guys back into the lab again, all right? And the theme of today is, what does an empirical formula lab look like? How do they figure out the formulas of some of these compounds that we've been talking about? So you guys know how to do it, calculating to generate the answer, but that's with me giving you the data to get started. Today, the idea is, how would you generate your own data? All right, so if you take a look up here, the goal of this lab is we want to determine what the empirical formula is of a manganese chloride compound. And that's this guy right here. Now, the reason I don't know what it is has to do with where manganese lives on the periodic table. So if you remember from last chapter, these elements that live in the middle of the periodic table, they always need a Roman numeral to tell us what their charge, which is an oxidation state, right, is going to be. So how do they figure out what those are? How do I know if it's a Roman numeral 2 or a 3 when I'm doing an experiment? Right? And because manganese has the ability to carry multiple charges, +2, +3, +4, we have to do an experiment to see which version that we are currently working with. Right, so that's what today's goal is in the lab. We want to figure out what's the formula of our manganese chloride compound. And once we have that, we would know what the oxidation state or the charge on the manganese is. All right, so how are we going to make that happen? Some similarities to the last lab, some differences. First thing we're going to do is we're going to go into the back, all right, and we're going to take an empty evaporating dish, all right? Then what we're going to do is we're going to put a sample of manganese into it. If you think about it, fundamentally, if I want to solve an empirical formula problem, right, I always say the first step of that is to get grams of each element. So if I'm trying to figure out X and Y, I need to get grams of the manganese in the compound and grams of the chlorine in the compound. All right, so those are the two things we have to do. We need to get our grams of Mn, and then grams of our Cl. All right, now I'll walk you through what the calculations for that are later, but right, that's always step one. And then once we had our numbers for each of those grams, then we converted to moles using a bracket problem, divided by the least, and we got whole numbers. So all we have to do is get these two values. One of the two is really easy to get. We're going to start with pure manganese, all right? And we're going to make sure that all the pure manganese that we use ends up in the compound. So I'm going to take an empty dish. Today we're not heating it strongly, so I don't need a crucible. I'm going to use just an evaporating dish. All right, so I'm going to take an empty evaporating dish. I'm going to see how much it weighs. Then I'm going to take a small sample of the manganese, and I'm going to put it inside of the dish. Right? And I'm going to weigh it again. You just got your first number. All right, by taking the dish by itself and the dish with the manganese, the only difference is how many grams of manganese we are going to put in our compound. Right, so that's the first thing that we'll do. Right, then what I need to do is get the manganese to create the MnCl compound. So to do that, I'm going to dump hydrochloric acid into the dish. And what's going to happen in the dish is, if I draw it like it's a beaker, you're going to have H's and Cl's in there, and you're going to have Mn's in there. And the Mn is going to come in and kick out the H. So the Mn's are going to connect to the Cl's in some fashion. We don't know what. And then the H is going to end up being separate, and because it's a gas, it's going to leave. Now, to ensure that all of the manganese ends up in this compound, that way our number is true for the amount of manganese in the compound, we're going to dump way more HCl in there than we need to, all right, to just initiate the reaction. We want to ensure that the manganese gets totally consumed, which is called being a limiting reactant. Right, but we'll tackle that later on in the year. So what's going to happen then is I'm going to have some leftover HCl that I need to get rid of, right? The hydrogen's gone, but the unreacted hydrogen chloride isn't. So what I'm going to do is I'm going to heat it on a hot plate to evaporate that liquid, right, HCl, and what's left behind at the end should be my manganese chloride compound. Right? And that's all the pieces of the puzzle I'll need to be able to get my chlorine. I can show you those setups while we're waiting for it to dry to get rid of the HCl. But let me walk you to the back and start getting some of our initial numbers so that you guys know how to fill some things in. Like if I share my screen with you, and I promise I will stop sharing it when I start doing the math so you guys can see. All right. All right. You just had me talk you through all of this stuff here. We're heading to the procedure. I'm going to go to the back. I'm going to get a chunk of manganese, and I'm going to break it up using a mortar and pestle to get about 0.25 grams. Then I'm going to get the mass of the empty crucible, or the empty evaporating dish, and I'm going to put it in the data table. Then I'm going to put the manganese in, and I'm going to record it again, and I'm going to put that in my table. So here's your data table here that you guys will be filling in. All right. Then I'm going to initiate the reaction by adding 10 milliliters of the hydrochloric acid. It's going to start fizzing when that happens because we're creating hydrogen gas. And we're going to let that go until all of the manganese disappears, till it all gets chewed up. Then I'm going to immediately put it on a hot plate to let the hydrogen and to evaporate the leftover stuff like I said. All right, then I'm going to show you guys how do we generate some of our numbers. All right, so let me take you to the back. All right, if we're heading back here. All right, here's my setup for the day. All right, here's my evaporating dish. Okay. I'm going to put a cover on it just so we don't splash anything out of it. And that's no big deal, right? As long as we get the weight of that too, it shouldn't factor into anything that we're doing. All right, here's my manganese. And if you've never seen it, it's just little black chip. Okay, and we're going to break one of those chips down. Right, but the good news is, because we've done this before, I have some smaller chips that we can use to get the mass we need. All right, here's my hydrochloric acid. All right, so the first thing I'll do is I'll come over here to the balance. All right, now I'm going to tell you guys the mass of the empty evaporating dish with its cover so we know what they are by themselves. So put those on up there. All right, that number is reading 53.40. All right, so in your data table, for that top line, mass of evaporating dish and cover, it's 53.40 grams. Then we're supposed to add a little bit of manganese. And the amount really doesn't matter, right? Because we're going to measure it in the crucible and the lid. They said use 0.25, right? But again, it doesn't really matter. I'm just going to take a little chip of manganese. I want it to be in the ballpark just so I don't have to use more acid than I need to. All right, so I'm not going to tell you that number because that number doesn't matter. What matters is the number once I take that little tiny chip and I put it in there and then I cover it with this lid just to make sure nothing got lost in the transfer. All right, so now I'm going to get the mass of this guy with the manganese in it. That is saying 53.40 Right, so 53.67. All right, so we're going to put that in the second line of our data table. All right, so 53.67. All right, and that's still what the number is reading over there. Great. All right, now from that, you can already do a couple calculations. All right, but we'll do that together while we're waiting for the reaction to occur. All right, the next thing I'm supposed to do, all right, if you look up in your procedure, all right, is I'm supposed to slowly add 10 milliliters of the 3 molar HCl to the evaporating dish. All right, and then I'm going to let it consume the manganese until it is gone. All right, so if we do that, I'll bring that over here. Take my lid here. I go into my drawer, get my graduated cylinder, carefully measure out 10 milliliters of my acid. Cover that back up. And I'm going to pour that into my dish. You guys can see that we're getting some bubbling. All right, one of our signs that a reaction's occurring. All right, so we're going to let that guy fizzle and bubble, fizz and bubble. All right, until all of the solid is gone. All right, while we're letting that happen, what I'm going to do is take you back up here and walk you through some of those calculations that you're going to have to do. All right, so in the meantime, just turning on my ventilation fan. And just like the last lab, you guys have to do some star calculations. All right, if you're going to do these star calculations, the first one is how do I get the grams of manganese? That one's straightforward, right? I have what the dish weighs. I have with the dish with just the manganese in it. That'll be a subtraction. So if I show that to you guys, right, I'm not going to do the numbers for you. But just like last time, I'm going to show you how. So if I want to get my grams of manganese, what I'm going to do is I'm going to take the evaporating dish, the cover, and the manganese. And I'm just double checking. Good, not presenting. Okay. Minus the evaporating dish and the cover. So that's going to get you some number for your grams of Mn. All right, that was your first star calc in your table. All right, you could also get your mole number of manganese, because remember, the whole goal of all of this is once we get the number for the grams of manganese, you can convert it into moles like we've been doing for all of our problems. And you pull that number from the periodic table, which if you take a look, manganese is 5490. So now you've got some number for your moles of Mn. All right, so you are halfway to getting your empirical formula in the first 3 minutes of us being into the lab. The second half is a little bit trickier. Right? If I want to get the chlorine nowhere in the experiment do I have chlorine by itself. And that's by design, right? Chlorine by itself is toxic. I don't want to create it, right? So I have it with the hydrogen chloride here, but it's a liquid, so that's no good in terms of getting its grams. That would be tricky. Furthermore, I told you we added more of that than we needed, so not all of the chlorine gets stuck in our compound. The only place then we have chlorine then will be here at the end of the process. After we heat it and get rid of all the hydrogen and get rid of all the leftover HCl, we'll have chlorine, but it's going to be stuck to the manganese. But the good news is you already know how much manganese is in that compound. So if you know what the whole compound weighs and you know how much of it's the manganese, you can subtract them to get how much chlorine you have. All right, so we're going to have to figure out how many grams of the manganese chloride we're going to get. All right, before we keep doing some calcs, let's walk back and see if we're still reacting. Right? If we are, we'll come back up. If we aren't, we'll move it over to the heat to start the evaporation process. So bring you guys back here. Tip this down for you. All right, so if you look in here, all right, there is no more black solid. It has all been dissolved. It's now part of the manganese chloride product. And because the manganese chloride is dissolvable, you can't see it right now. What we need to do is get rid of all that liquid and convince it to come back out. Basically, what we're doing from this point on, it's like when you leave a jar of sweet tea out on a hot summer day. If you let it go for forever, you'll find the crystals at the end. That's what we're going to do. But we're going to help it along by putting it on the hot plate. Right, so I'm going to come over here. I'm going to set this carefully on the hot plate. I'm going to cover it just so it doesn't splatter. All right, taking a look. And what's going to happen is we're going to heat that liquid up until it evaporates, right, or even boils a little bit, right, away. Right? And once it's all gone, the stuff that's left in there, you will see there will be solid that you couldn't see before. That's going to be your manganese chloride. Right? That takes some time as well. So let me take you up here and we'll walk through some other calculations. Okay. All right. So like I said, if we're going to figure out our manganese chloride, we have to be able to get the chlorine by itself, right? And we can't do that, so we do the next best thing. We get it with something else that we know how heavy it is. So one of your star calcs is going to be, how do I get the grams of manganese chloride? All right, so the only place we have the manganese chloride is here at the end of the experiment. That's what's going to be in my dish when we're all done, right? The manganese chloride. But when I weigh it, the dish and the cover's weight is going to be attached to it. Right, so what we can do is we can take the grams of the dish, the cover, and the manganese chloride minus the dish and the cover. Dish and dish nullify, cover and cover nullify. The only difference between those number values are going to be the grams of manganese chloride. All right, so that's how you'll get that value. All right, so now what you'll have is you'll have your manganese chloride, the stuff at the end. You'll have the manganese from the beginning. The only difference between those two weights is going to be the chlorine. And last time it got lighter when we heated it because we had the oxygen leaving. Believe it or not, this time it's going to get heavier because I started with just manganese and I attached something to it. So when I weigh that evaporating dish at the end, it should absolutely positively weigh less or weigh more than it did at the beginning. And that added weight is going to be how much chlorine attached, which is what we need. Right? So the last calculation that's going to let us jump to here, right, is getting the chlorine. So let me show you that. All right, so if we want to get our grams of chlorine in the column, what we need to do is take the grams of the manganese chloride, which I just showed you how to get, minus the grams of the manganese. And what you'll have is grams of chlorine. You just got that number. And once you have that number, now you can finish your problem, because the rest of the empirical formula problem that we traditionally do all comes from the periodic table. Grams on the bottom, moles on top. One goes with moles. Chlorine's number is 3545. That's going to get me moles of the Cl. Once we get our mole numbers, the next thing we always do is divide by the least. That gets us our new numbers. All right. And I'm going to let you guys do that, because if I use the lab numbers, you won't learn any. You won't have to practice anything. All right. So that's why I'm writing the number sign so much. These will all be gotten from your experiment, from the numbers we pulled from the balance in the back. All right. Here's a difference between an in-class problem and lab. In class, we would do the multiplier if it wasn't 0.0 something or 0.9 something. All right. In the lab, we will simply round them to the nearest number. So these guys here round to whole numbers and then use them in your formula. Mn x CLY. So whatever the Mn's number is will go here, and the CL's will go here when you round them. And that's a slight difference, right? I can't control the lab numbers that you get. Now, mine will be pretty reliable, but yours wouldn't be. So I always have you guys round. All right, so we're going to take a look in the back, see how our evaporating process is going. All right, if it's done, we'll go ahead and get a mass, but it's kind of early for that to happen. If it's not done, what you guys can do, right, is the few star calcs that you're able to, and you can start working on some PostLab stuff. So if you take a look, still liquid in there. All right, we got to let that keep going. I'm going to walk you guys through what you need to be worried about for your lab report and what you guys can be working on right now. All right, so let me go back in here for a second. Okay, and I will share my screen with you now. Okay. All right. So if you guys take a look. All right. We're still just sitting right here. You can do your star calc for the mass of manganese. You can do your star calc for the moles of manganese. I already talked you through those. All right. We still wait on this number. So you can't do any star calcs after it until we get that number. What we can do, though, is do some PostLab questions. All right, so PostLab 1, right, is a percent comp question. You can do the first half of it right now. It says determine the theoretical and experimental percent comps of the manganese 1 chloride. So I'm saying let's assume it's going to be a Roman numeral 1. Theoretical percent comp, all the numbers come from the periodic table. So you can write yourself a formula for the manganese 1 chloride and then use the periodic table to get your percent of manganese and your percent of chlorine. You can do number 2. It's going to be just like the empirical formula problems we've been doing. I've given you the grams of a compound that has phosphorus and oxygen. I'm telling you how much is phosphorus, which means the 20.30 minus the 8.87 must be the oxygen. Now you have grams of each. Convert grams into moles, divide by the least, get whole numbers. 3 is another empirical formula problem. I give you the percentages of the elements, same thing. Follow your notes, you can solve that problem. 4. 4 is a molecular formula problem. All right. Today, right before we went into the lab, I showed you guys how to get molecular formulas, right? Use that to solve number 4 here. You already have your empirical formula from 3. So in 4, you just have to get what your multiplier is, your molar mass divided by your empirical mass, and then distribute it like we were talking about. So you guys can be working on those while we're waiting for our substance to evaporate away. All right. Similarly, you could be taking care of some of your lab things. All right. And what I would do with my partner, like last time, I would create a shared document, electronic title, electronic purpose. Don't worry about the procedure. All right. So don't worry about the procedure. Your data table, create that data table, which is this guy. And remember, data tables all have numbers and units, but they do not have calculations. So don't show any of your subtractions in that table. Don't show any of your bracket problems or your empirical formula problems in that table. It is simply final answers. It's a list of final answers. All right. But that's in your electronic lab report. Now we get into the non-electronic. All right. A, B, C, D, E, F, and G. Those are all going to be handwritten. A through F or your star calculations. Just like the last lab, you have a separate piece of paper with those worked out. The G is the PostLab questions. Again, those are math questions. You can handwrite those out and share an image of that as well. All right. 5 gets you back to electronic. All right. The 5-part conclusion. And remember your steps to the 5-part conclusion. All right. Restate the purpose. What were we trying to accomplish? 2, did you fulfill the purpose and how? All right. 3, how does this relate to class? 4, what are some sources of error? What would make me not get the right mass that I was supposed to, or the right formula I was supposed to? And then lastly, difficulties. And obviously you guys won't have any of those because I was conducting the experiment. You guys physically didn't do. All right, so let's pit stop to the back and take a look and see how our evaporation is going. All right, so coming along, but still taking some time, right, to evaporate that out. And it's a process. It takes time. All right, so what you guys want to do now, all right, is start working on those post-lab calculations. All right, what I'm going to do, all right, is I'm going to let that finish up. And then what I will have sent to you guys is I'm going to send a picture of the product so you can see what it looks like in the dish. sitting on the balance so you can see what its numeric value is. There's no need for you guys to sit here and watch that occur. All right. So it's still going to take a little bit of time for that to evaporate. But again, you guys can be productive working with your lab partners, work on those PostLabs, work on those few star calcs you can get, and sent to you guys, right, as a whole class, right, is going to be a picture with the final product sitting in it on the balance with the number you need to fill in your last number for your data table. And if you have any questions, right, jump back into the main room. Otherwise, I'll be cycling through your breakout rooms and trying to help you guys in any way that I can. I hope you guys have a good day.